These are examples from section 5.2, triangle midsegment and angle bisectors. Example 1. Use the triangle midsegment theorem to write statements for all three midsegments of triangle DEF and write the relationships of parallelism and length. Before we can do that, we need to review what the triangle midsegment theorem contains, the midsegment and the definition of midsegment. The midsegment of a triangle is a segment that whose endpoints are both on the midpoints of two of the sides of the triangle. For instance, RT is a midpoint of triangle DEF because R's is an endpoint and it's on the midpoint of DE. T is the other endpoint on the mid, and it's the midpoint of DF. So RT is a midsegment. Similarly, RS is a midsegment, and ST is also. So starting with RT, using the midsegment theorem, there's two parts of it. It states that if a segment joins the midpoints of two sides of a triangle, then the segment is two things: parallel to the third side and is half as long. So we're going to write three parallelism statements, and then we're going to write three length statements using the midsegment theorem. Starting with parallelism, let's take midsegment RT. According to the theorem, segment RT, midsegment RT, is parallel to the third side. The third side is the side that is not touched by the midsegment, so that would be EF. So RT is parallel to EF. Then RS is the midsegment, another midsegment, and is parallel to its third side, DF. So RS is parallel to DF. And finally, the third midsegment, ST, is parallel to its third side, which is ED. ST is parallel to the third side, DE. For the second part of the midsegment theorem that states that the midsegment is half as long as the third side, starting over with RT, the midsegment, this midsegment is half the length of its third side, which is FE. So the length of RT equals half the length of EF. Notice there are no segments over these. Distance. The next one, RS. The length of RS, that midsegment, is equal to half the length of its third side, DF. And finally, the last midsegment, ST, is half the length of its third side, ED, or DE. Example 2. In triangle QRS, T, U, and B are all midpoints. So T is a midpoint of QS, B is the midpoint of RS, and U is the midpoint of QR. Therefore, these three segments, TU, UB, and QR, are all midsegments. They're asking for the length of those three the lengths of these two midsegments, UT, or TU, UB, and then they're asking for the length of QR, right here, whose midsegment is TB. Recall, by the triangle midsegment theorem, the length of any midsegment is equal to half the what? The length of the third side, or its third side. So starting with TU, midsegment TU. Midsegment TU is what we're looking for. So according to the theorem, the length of TU is half the length of the third side, or its third side. TU's third side would be RS. Substitute in what you know, TU, we're looking for, equals 1/2 the length, or times the length of RS, which we're given as 40. And solve. TU is equal to half of 40, or 1/2 times 40, which is 20. TU is 20. For the length of midsegment UB, we use the same theorem. UB, the length of UB, is half the length of its third side. UB's third side is QS. Length of QS. So UB, what we're looking for, is equal to half the length, or times the length, of QS, which is given as 50. Solving the equation, UB is half of 50, or half times 50, which is 25. So UB is 25. And then to find the length of QR, which is not a midsegment, but one of the sides of the triangle, we've located its midsegment, which is TB. So the length of TB, the midsegment, is equal to half the length of QR according to the midsegment theorem. Substituting in what we know, TB is given as 30, equals 1/2 times the length of QR, which we're looking for. To get rid of the 1/2, we multiply both sides by 2. The 2's divide out on the right side, and we're left with QR. On the left side, we get 60. So QR is 60. Example 3. Verify the triangle midsegment theorem for triangle ABC using one midsegment. First, find the midpoint D of CA. So D will be the midpoint of this one, this side. And the midpoint E of CB. So E will be the midpoint of this side right here. Then show basically what the triangle midsegment theorem says, that DE is parallel to AB, and that the length of DE is half the length of AB. So once we get the midpoints of these two sides, we can draw the midsegment for one of the midsegments for this triangle, and then we can apply the midsegment theorem to see if it works. Step 1, find the midpoints D and E. So to find the midpoint of D, since D is going to be the midpoint of AC, we find the midpoint of AC, which is D, which according to the formula for midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. So A is an endpoint and C is an endpoint. C is at 0, 0. C is my second point, so I'm going to start with x2, which is 0, plus x1, which is 4 over 2, comma, now for the y's, back over here, 0, plus 6 over 2. That gives us 0 plus 4 is 4 over 2, comma, 0 plus 6 is 6 over 2. Simplifying further, we get D, the midpoint of AC, is at 2, 3. So let's see if that worked. Start at the origin, go to the right 2, up 3. And there is D, the midpoint at 2, 3, the midpoint of AC. Now to find the midpoint of BC, right here, using the same formula, this time we're going to find point E, which is the midpoint. So starting with C this time, I'm going to let this be my first point, so that would be 0 plus the x-coordinate over here, 6 over 2, comma, back over here, 0 plus 0 over 2. Simplify. 0 plus 6 is 6 over 2, comma, 0 plus 0 is 0 over 2. Simplifying again, we get E, the midpoint, at 3, 0. So the midpoint of BC is at 3, 0. Check it out. Start at the origin, go to the right 3, go 0 up or down, and there's our midpoint. Midpoint E at 3, 0. Take a straight edge and draw that midsegment. Step 2. Now we start to verify the midsegment theorem. The first part of the midsegment theorem states that the midsegment is parallel with the third side. If those two sides are parallel, DE and AB, then on the coordinate system, their slopes would be equal. So we're going to use the slope formula to verify that the slopes of these two segments are in fact the same, and therefore the segments are equal. So we're going to verify that DE is parallel to AB. So, put a little question mark there. We need to find the slope, little m, of DE, and then we need to find the slope of AB and see if they're equal to each other. Using the slope formula for DE and the endpoints of DE, we take y2 minus y1 first. E is my second point, so we're going to say 0 minus 3 over x2 minus x1, 3 minus 2, equals, hopefully, the slope, using the slope formula for AB. B is my second point, so starting with 0, the y2, we have 0 minus y1, 6. Go back over to B, our second point, x2 is 6 minus x1 is 4. Now let's see if this yields the same slope. 0 minus 3 is negative 3 over 3 minus 2 is 1. 0 minus 6 is negative 6. 6 minus 4 is 2. Simplifying further, negative 3 divided by 1, or negative 3 over 1 is negative 3. Negative 6 over 2 is negative 3. Therefore, since the slopes are the same, DE is indeed parallel to AB. Step 3, the second part of the midsegment theorem, we verify the lengths using the distance formula since we're on the coordinate system. So again, by the midsegment theorem, we're going to show or try to verify that DE, the length of DE, would be equal to half the length of AB, the third side. Using the distance formula for DE here equals 1/2 times the distance formula for AB here. For DE, D is my first point, E is my second point. So using the formula for distance, we start with the second x-coordinate 3. When we have 3 minus the x-coordinate 2 squared plus, back over to E, we have 0 minus 3 squared equals 1/2 the length of AB. The length of AB, use these two ordered pairs, let B be my second point. So x2 is 6. So it would be 6 minus x1, which is 4, quantity squared, plus the distance formula states, back over here to 0 minus 6 squared. Now we simplify this and see if the left side equals the right side. 3 minus 2 is 1 squared, plus 0 minus 3 is negative 3 squared, but don't forget, put those parentheses in, equals 1/2 times 6 minus 4 is 2 squared, plus 0 minus 6 is negative 6 in parentheses squared. Simplifying further, 1 squared is 1, plus negative 3 squared is positive 9. So we have the square root of 1 plus 9 equals 1/2 times 2 squared is 4, plus negative 6 squared is positive 36. 1 plus 9 is 10, so we get the square root of 10 equals 1/2 times 4 plus 36 is 40, so it's times the square root of 40. At this point, when you get numbers underneath the square root, go ahead and take a calculator at this point, and we're going to approximate to the nearest hundredths place. Take the square root of 10 in your calculator, find out what that is, rounding to 2 decimal places. That's 3.16. We use approximately equal to, since it's a decimal that goes on indefinitely, equals 1/2 times the square root of 40. Putting that in your calculator, we get times 3.16. One last step. 3.16 is approximately equal to, clear your calculator, put in 3.16, and take half of it or divide by 2, and you do get 3.16. Therefore, DE, the length of DE, is equal to half the length of AB. We verified both parts of the midsegment theorem after we found the midpoints. You could do a similar thing with the other two midpoints or midsegments in this triangle.